All right. Hello, everyone. Thank you for tuning in to the last Corundum developer meeting for 2023. The next couple of Mondays are holidays, so um, this will be the last one for 2023, and then we'll pick up in January. So yeah, agenda got basically announcements slash meeting planning and project ideas and status updates. So right now, I haven't decided exactly what I want to do for the meetings in 2024. So I think there's basically two options. Well, probably at least two options. The first thing is to keep doing the same thing that we've been doing, just 9 a.m. PDT every other Monday, starting on Jan 8th. We could keep doing that. But I'm wondering if it makes sense to switch things up a little bit and to meet once a month instead. And the other thing that I know that is problematic for some people is just the time. There's certain time zones where that ends up being like the middle of the night, which is not so great. So what I'm thinking about doing is basically holding the meeting once a month, but then twice. So once at 9 a.m. and basically make the same presentation at 9 p.m. as well. So 12 hours apart. And that hopefully will be better with time zones and whatnot. People in far-flung parts of the world. So for that, we'd start on January 3, and I'm thinking something like a Tuesday, Wednesday, Thursday, something like that would be a better idea than Monday or Friday, because that's going to avoid a lot of holidays and whatnot. So should end up with a more consistent schedule. Or potentially open to doing something else. So I don't know if people have thoughts about doing something like that where we do a meeting once a month but then run it twice. We can discuss that here. We can discuss that later if anybody has any thoughts one way or the other. The other reason I think I have for changing to once a month is that if you're doing something like every week, it's almost kind of a low bar to attend. So you can go like, yeah, I'll tune in next week. Yeah, I'll tune in next week. Yeah, I'll tune in next week. And then, you never actually show up and connect to it. But if it's once a month, maybe that's, maybe it'll be more encouraging people to, actually tune into the meeting. Because, well, it's going to be a whole month until the next one. So we can try it anyway if nobody has any thoughts about that and see how it works. So that's all I wanted to say in terms of the announcements. Not sure at this point which way. If people have thoughts about that, we can discuss that on Zulip and figure out which path we want to take. All right. So moving on, project ideas. Again, I'm not going to go over this in too much detail. People that want to get involved in the project and want to pick something to work on. Here's some ideas. I've talked about these in the past, so you can go look at some of the recordings. I'm also happy to discuss any of this stuff, after I go through the status update slides. If anybody has any questions about any of this. All right, so moving on to the status updates, a couple of main things that I want to touch on here. Over the past couple of weeks, I've been taking a look at some of the queue management code and made a few insights and a few adjustments to that. That's definitely very much in progress. Getting that operational and updated again. I've also been putting some thought into updating the scheduler and internal flow control to better support multiple ports on one interface and avoiding internal header-line blocking and whatnot. And I have a few ideas for how to make that work and scale to a decently large number of ports. And then also touch on the application section pass-through and the test bed that I've been slowly piecing together. All right, so for the queue management, I'm resurrecting the code for that. Again, I think the last time, I think I ran into a major PCIe issue that resulted in then getting sidetracked. But there are also some performance issues with the rewrite that I was working on, so I had to hunt down a few bottlenecks in that before it was going to be appropriate to switch over to using it. So what I've been doing over the past couple of weeks here is getting that code running again, and then taking a look at some of the performance issues and figuring out how to solve those. So first thing is basically reworking how the queue state is stored in the management logic. And I came up with this idea for doing a split pipeline that I'll talk about in the next couple of slides here. And also some ideas for improving the event generation, which breaks the back pressure path, so we don't have to worry about, okay, if we can't generate an event right now, can we make progress on doing other things? And then also to rework the slot allocation in terms of the new logic, which can do batch completion right back. It has to keep track of those in a set of these little scratch pad RAM locations, and basically reworking how that logic has been set up to hopefully remove a couple of additional bottlenecks, but potentially also introducing some other issues that I have to sort out. So yeah, one step at a time. So yeah, for the queue state storage, this is what it looks like right now. Pretty straightforward. What previously I was thinking about going for something like this. The idea is we're moving from separate TX and RX queues to doing queue pairs, which store basically 2 copies of all the queue state information, except for the base address and except for shared stuff like the base address and the VF number. And then those would be basically amortized across both the send queue and the receive queue. So you save a whole ultra-RAM block while getting, a decently large number of queues. And then I added a couple of additional fields like the LSO offset, which would help with if you wanted to implement LSO, TSO, you have to be able to store an offset basically into the current frame as you're generating the pieces. So the idea is to put that in the queue state. And I think there was, let's see, what else did I do? I removed I removed the op index field and made a couple of other minor changes. But yeah, the main thing is, combining the TX and RX queues into the same structure. But then after some realizations that I'll talk about soon here, I decided to basically bring back that internal slot field and remove the LSO offset, because with the slot field, I then wouldn't have enough space for that. And a couple of other minor modifications. So this is kind of what I'm looking at going with going forward. And we got the same kind of thing in terms of this fits into 3 URAMs for the queue pair. So you still get that amortization going on. But yeah, one thing you'll notice is that there's some duplicated stuff. So there's 2 enable bits here, and there are 2 log queue size fields. I was thinking about bringing that down to 1, but the idea is that this supports storing the send queue and receive queue state fully in 2 separate RAMs, which brings me to the split pipeline setup. So that requires, in order for that to work, there's a little bit of information that has to be duplicated. The enable bit has to be duplicated, and each queue has to have its own log queue size field, even if they're set the same way. So the idea with the split pipeline is that you can have operations against the send queue and the receive queue basically take place in parallel without interfering with each other. So this was the one thing that I was trying to figure out in terms of the if we're going to implement queue pairs, I don't want to have the transmit and receive operations interfering with each other and reducing the throughput, the packet rate that you can get. So part of the issue here is in terms of just the shared stuff, right? The address, because they both need to know that. And then the other part is to, split up the queue state appropriately. So basically with this setup, during, normal operation, if you're just managing the slot state, you don't need the addresses. You only need that if you're actually performing a DMA read for, the transmit receive queues, or DMA write for the completion and event queues. So when you want to perform that operation, then you would basically send an offset through the address pipeline to produce the actual DMA address that you would use for the operation. And having that be shared is not really a big deal because the DMA engine is shared anyway. So, you don't really gain anything by duplicating that. But by splitting the SQ and the RQ, that's a pretty significant advantage. For register operations, those might need to hit multiple. So, for example, for the AXI Lite operations, you have to check to see, whether the queue is enabled, and also whether or not there's, any current processing active on that queue before you can change certain pieces of information. So for that, you basically need to read everything, because each of the active bits are inside of the SQ and RQ pipelines. And then, the address and VF number are in the address part. So you might have to read everything. There's potentially operations where you could, only issue it on a couple of pipelines instead of all three of them. So there's potentially some room for optimization here. But I've gone ahead and updated the completion queue handling code that I've been working on with this new split pipeline setup, and tested that in the hardware. Seems to work just fine. So obviously for that one, you only have two pipelines, just one for the completion queue logic and one for the address. I think you still get a little bit of advantage there, because now you don't need to keep track of the address information inside of the slot state. Every time you want to make a DMA operation, well, you can just, issue that on the address pipeline here, and everything works. So that's been tested in hardware, and that's going to be part of the updated code. The next thing that I was taking a look at is the event generation. Basically, the event generation from the completion queues has potential for some back pressure problems. And the main reason for this is that events can be generated in response to register writes. Basically, if you perform a register write to rearm a completion queue, and that queue has data in it, then you need to generate an event such that that data will actually get processed by the driver, and the queue will get cleared out. So the initial rewrite of the logic that I did had a contention problem related to rearming. Basically, when you rearm the queue, then that operation would have to loop all the way back through the main pipeline. It would have to allocate a new slot, and yada yada yada. It introduced a number of bottlenecks and potential performance problems. And also, if there weren't any slots available, well, do you have to hold up future register operations until there is a slot available so you can allocate it? It was not great. But I realized a couple things. First is that when you rearm a non-empty queue, you don't need to wait for a timeout, which is why I was allocating slot. You can just generate the event immediately. So if we move the event generation into the queue state management logic instead of the queue management logic, then we can do that. So to facilitate that, the other thing I did is I added a pending bit, and then the idea is that whenever you want to generate an event, you just set the pending bit, and then we have a background scrub that will go through and check to see if a pending bit is set. If it is, then it'll generate an event and clear that bit. So because of this, background scrub and pending bit setup, well, we've now totally broken the back pressure path, because we can always set that pending bit without having to wait around for something. So this is definitely going to be a significant improvement in terms of how the queue management is set up. And the other thing I realized as well is that the only thing the event queue number is used for is the tdest in the events. So for generating the events out of the queue state management code, then I don't need to have the event queue number in the slot state. So that removes a few distributed RAMs. And the idea is to use the same scheme for event queues, because those potentially have the same problem, where you can only generate IRQs at whatever rate the PCI Express interface allows you to generate memory writes. So, I mean, honestly, you shouldn't be generating that many in the first place, but If you do need to generate a bunch for some reason, if it's a burst, you don't want that to back things up too much. So the status is I've gone ahead and updated the code that I've been working on, the in progress code, and tested this in hardware, and it seems to work. So that's good. Let's see. And then the other thing that I'm working on right now is adjusting the slot allocation handling. So previously, this was handled outside of the queue state management. So basically, I have an inner module that handles the queue state and the pipelines and the RAM, and then externally I have another module which manages the slot. So there's a scratchpad RAM that stores the actual completion data. So the queue state management originally didn't know that slots even existed. It could just mark a queue as being active, or fetch information about it, update pointers, things like that. But then we had this rearming problem, which resulted in a bottleneck at the component that actually maps the completion queue number to the slot, because that's used for not only sending a packet, right? If you want to end queue a completion on a particular queue, you have to figure out what slot it is that you're using. But also these update events also went through that bottleneck as well. What I realized is that, okay, if we put the slot in the actual queue state and make it aware of the slots, and obviously we have to consume a few of our precious bits for that, then this fixes some of these problems. The other thing I realized as well is that, well, if we're going to store this slot in the queue state, why don't we make the queue state logic manage a slot allocation as well? And this actually simplifies a couple of other aspects of the setup, and potentially also enables a higher throughput, because I had some wonky simplified back pressure stuff that was limiting the rate. And yeah, it would also potentially remove a few additional choke points and simplify the logic. So I'm working on that. I have it partially working in simulation. There's a few pipeline hazards that I need to sort out, which hopefully won't be all that much trouble. But when that's done, hopefully this is going to be working at a similar level as the previous setup. But yeah, that's what I've been working on over the past couple of weeks, and it's slowly coming together. All right, so just kind of a summary of this. We've been working on resurrecting the logic for batch completion right. I have the RAM layout updated and tested in hardware, right? Just adding the slot and the pending bit to the queue state and moving things around a little bit. I have the event generation from the queue state module set up. So that's pending bit, and then also the background scrub. So that's done. I have the new split pipeline set up, implemented in the queue state logic. So that's done. And the new slot allocation, working on that. So hopefully that won't take too much longer to get that squared away. So longer term, once that's finished, then it's on to the updated descriptor fetch logic, as well as the queue pair management. So the queue pair management, that's just going to be basically a modification of the completion queue state logic. But the descriptor fetch logic, that's going to be probably a little bit more complicated, because there's a lot of moving parts for that to work. And it's obviously a slightly different story than batch completion right, but similar idea. I also have a couple of ideas for how to improve the completion right code as well, in terms of improving the allocation of the actual memory that's used in the slots. But I'm going to put that down for an optimization on a different day. We'll get the basically the reworking of the slot management done first, and then potentially look at some other optimization techniques a little bit down the road. All right, so the other thing that I've been looking at as well, that I mentioned before, is basically better support for multiple ports on one interface, such that we can basically move the entire design over to using that instead of having multiple interfaces. And we'd save logic resources by doing that, and make things a lot more flexible at the driver level. So as part of that, one thing I need to do is make the scheduler work with multiple ports. So the current scheme is you drop down one scheduler per port, which I mean, it works, but it has some limitations, and it also eats up a lot of logic resources. So what I'm thinking about doing is basically baking in support for multiple ports and also multiple priority levels to the current scheduler. And the idea behind this is pretty straightforward. It's going to round robin across all of the ports and then have priority arbitration across the priority levels, for each port. So the way the scheduler works internally is pretty straightforward. It has an internal FIFO, and whenever a queue wants to send, or whenever a packet gets enqueued in one of the transmit queues, it'll send its queue ID via doorbell request to the scheduler. The scheduler will then take that queue ID and stick it in its internal FIFO. And then whenever there's something in the internal FIFO, it'll pull it out and issue a transmit request for that queue ID, and then it'll loop the queue ID back around and put it back in the internal FIFO. And there's some logic to look at all of the outstanding transmit requests and figure out, okay, are we getting failing transmit requests for this particular queue? And if that's the case, then it will be removed from the FIFO and basically put back into an idle state. So for each port and for each priority level, you need to be able to keep track of this internal FIFO. And that's basically what I need to put together for the for this module. And what I'm planning on doing is using linked lists. And I have some ideas for how to hide the pipeline delays. So the problem with UltraRAMs is you have to add 2 or 3 at least cycles of pipeline delay. And from the scheduler standpoint, that's going to limit basically the packet rate that you can get on a single queue if you have a big long pipeline delay. So I've got a couple of ideas for how to, well, I guess it limits the packet rate, period. If you have to walk a linked list, that would limit the packet rate on a single port at a single priority level due to walking that linked list. So that would be potentially problematic. And then if you have just a single queue active, the number of cycles it takes between when you make a transmit decision and put that queue ID back into the scheduler versus and when you get it out of the scheduler again after propagating through, that's going to determine the maximum packet rate on a single queue. So that's one thing I've been trying to figure out is, okay, if we're going to do linked list, how do you make walking that relatively efficient? And then also, how do you shorten the pipeline delay such that you can keep a high packet rate for an individual queue? So I've got some ideas on that front and starting to piece together an implementation of what that's going to look like. The other thing that I have to implement as well is the internal flow control, where the scheduler will keep track of basically a quota for each port and for each priority to prevent headline blocking by filling up the transmit queues and whatnot. And also make sure that if you have high priority data to send, that you actually have some space in the transmit queues available to send that data. So that's the other piece that I'm starting to work on here. And I guess the other component that we're going to need as well long term is using some sort of shared memory approach for the output FIFOs. And I think Carlos said he wanted to take a look at that. So hopefully there'll be some more details on that at some point once we've sunk our teeth into that a little bit more. All right, so a couple of points from previous meetings that I wanted to bring up here. So the application section passed through. Now that the main repository has been updated, I'm now awaiting the MLE guys to put together a pull request for that with their changes. I'm not sure if we have any status on that, Ulrich.
Yeah, we got a bit sidetracked last week's, but it should be available before Christmas, actually.
All right. I mean, getting sidetracked, it happens. So nothing wrong with that. Happens to me all the time. But yeah, okay. So at some point we'll have that, and then I'll get that merged in, and everybody will be happy, hopefully. So
great.
I think you guys also opened another pull request on the I2C stuff that I need to take a look at. So yeah, more stuff on my to-do list.
Yes, there
Anyway,
was something. Yeah. Okay.
yeah. All right. Sounds good. Right, and then the shared development testbed updates on that. I've been slowly piecing together the actual, testbed setup. I bought a bit of single mode fiber before. I thought it was like a large amount. It was like 20 fibers. I've used all of those, hooking stuff up. So I just ordered some more fiber. I think that just came in a day or two ago. So got to get more stuff hooked up. The other thing that I finally got my hands on is one of the actual Viavi QSFP28 adapters for the network tester thing. One of these guys. So this one will allow me to put a QSFP28 in the other port of my network tester and actually, run it at 25G and communicate with it properly. So this is great because I now can run both ports on this thing at with the CWDM4 modules, and at least one of them I can run at 25G if necessary. The problem with the other adapter I have is that it mixes up the lanes, so it works at 100 gig because 100 gig is capable of, putting everything back the way it's supposed to be. But 25 gig, you just have one transmit, one receive lane. So in order to use that other module, I'd have to like transmit on lane 0 and receive on lane 2 or 3 or something like that. The software on this thing doesn't let you pick different transmit receive lanes. It's kind of annoying, but this thing works. So that's going to be a nice setup. Yeah. So I got the fiber. I got this thing. I also put together another little computer to use as a control host and VPN endpoint and whatnot. So I've been getting that set up as a DHCP server and yada yada yada. I also need to figure out the remote access solution, probably some sort of a VPN. There's a couple of potential routes that I could go for that, but haven't figured out what's going to make the most sense yet. Once I get that sorted out, then I can certainly provide access to people that want to do stuff on there. So I think that's potentially going to be useful for Carlos and testing the switch stuff out. But yeah, hopefully soon that'll be in a place where it's going to be useful by people in the community. And now I'm not actually just going to provide access to everybody. You're going to have to ask me directly if you want access to it, then I'll generate the appropriate keys and grant access and whatnot. Because yeah, providing access just publicly to computer systems is generally not a good idea. Anyway, I think that's about all I got in terms of updates today. So we can now open it up to questions and discussion. If anyone has any questions about stuff that I've talked about or anything that they want to discuss separately, we can do that. Nobody has anything they want to discuss?
Santa Claus dropped off my new bitwar card today, so I'll start looking at porting to the VB4.
VB4 or VB8?
No, it's an older one.
Oh, it's an older one. Oh, okay. All right. So that one, does that have QSFPs or QSFP DDs?
QSFPs for them.
Okay. Right. So I think we briefly discussed the I think they're VB8, the QSFP DDs. But okay. So with the QSFPs.
I think it's a 13P, right? I think it's a 13P ultra scale.
Right. Is that the one that they have the water cooled version of?
They do, like mine's air cooled.
Right. Okay. Yeah, I think there was I was talking to somebody on the Corundum Zulip like a few months ago who got the water cooled version of one of those, but I guess it was like a used card and it didn't work. There was like something wrong with the board management controller or power supplies or something. So that ended up being a dead end. But I think he ended up sending it back. But yeah, those are supposed to be pretty good cards with the 13P on there. I don't know. I guess they originally made those for mining or something. So you have plenty of power supply capability, and then coupled with the water cooling to get all the heat out. So personally, I've never bothered with those because getting the whole water cooling set up so you don't melt the card is slightly annoying, but you know, I guess getting the air cooled one means you don't need to deal with that. So hopefully it works.
Yep, I'll let you know.
And it should be, I think, a relatively similar setup to the XUP P3R card, right? It's the same, you know, 4 QSFPs. So hopefully that would be a relatively straightforward thing to port.
Yeah, I've got both hardware manuals up here, so I'll start sorting through it in the next week or two.
Right. All right. Well, hopefully that goes well. Hopefully it's easier to deal with than the Acronix units.
Oh my God, I think I'm on my 3rd card now. I keep blowing them up.
The Acronix ones?
Yeah, I keep sending me new ones. I keep finding bugs.
Well, I mean, it is an Acronix, right? That's I guess what was the scientific term for the spider, right? That's arachnid. So it's close.
Yeah, no, I've because I'm doing 400 gig on that one, and I keep finding issues that they keep telling me they're already fixed. It's not in the card that I've got or the version I've got. So.
Yeah, that's a pain. Well, I know we took a look at the CMS, or not the CMS, the management IP, the management interface for the QSFP DDs. Did you end up? Well, I guess.
Yeah, I think we've actually made some progress. I got an FAE who's the troubleshooting in the lab. I sent them a whole bunch of the DDs and the breakout fibers and whatnot, so they can replicate what I was doing. But yeah, I'm learning a lot more about I2C programming than I ever wanted to.
Yeah, well, it's good stuff to know, because occasionally you'll bump into that and it's like, okay, hey, great, we just write these registers and then it works. Hopefully.
Appreciate all your help, though. I do owe you a beer that send in.
Yeah, well, hey, it'll be great when that thing works. Might not be that card, you know, but something.
Yeah, well, Arista was nice enough. They're sending me a 400 gig switch for these too, so I'm going to be busy over Christmas.
Wow, that'd be fun to play with. All right, Julian, did you want to say something, or you're just
Yes, I raised my hand virtually because of this.
Right.
Yeah, 2 things. I'm still working on I heard you talking about small cards used for Bitcoin minings, and I found a small one based on the RTX 7, and I'm still working on this one on the hardware level for now. And I'm at the very beginning, but I would like to succeed. I think it's possible to run Corundum on this even slowly.
So you said it's an RTX 7?
Yeah, it's a small one, very small.
And so it has what, PCIe and.
In fact, it's a card which has a PCIe 4X, and I'm stealing 2 lines of PCIe to drive SFP instead.
Okay, is that one of those little kind of M.2 form factor cards?
Yeah.
Okay. Yeah, I've seen those things. They're kind of cool little cards.
They are cool, and they are very not too expensive. So if I burn everything, it's not too bad. And so I broke the components to to break the wires that goes to the PCI and wire that to at least one SFP cage.
Do those serializers on there support 10G, or do they top out?
No, only 1 gig, I think.
Right. Okay.
Yeah.
Yeah, because I know that's the problem with some of these parts is that they go to like 6 or 7G or something like that. It's like not
no, yeah.
It's enough
For
for PCIe Gen 2, but not enough to get all the way to 10 gig. So
yeah,
that was
exactly.
one
So
thing
what
that-
my
yeah, that was one thing I liked about it. I think there was a Stratix 10GX. That one actually, they have series that go all the way up to 10G on those things, but
yeah.
there's not too many
But
of those boards that
yeah,
parts available
for
on
now,
board,
my
so.
aim is to do it work at 1 gig at least, and see after what I can succeed in doing on this. Maybe I can go up to 2.5G, but that's a dream.
Yeah, that could be cool. So one thing, I'm not sure if the Arctic 7 is fast enough for this, but I know quite a few of the Xilinx devices, you can do 1.25 gig out of normal IO. You don't need the serializers for that. I'm not sure if the Arctic 7 goes fast enough for that. I'm also not sure if they have
I'm not
any IO
sure.
brought out that would be appropriate. But you could take
the-
that potentially and connect it to an SFP and run at 1 gig.
Yeah.
Or SGMI to a PHY chip.
The issue here is that the regular IO, they don't do the LVDS stuff to drive the SFP directly. So if I want to do that, I could do that, but using a component in between to translate, regular TTL levels to SFP levels, and that kind of component is very difficult to find and to make on the little board because they are running very fast. And since I really want a SFP and not a regular Ethernet port,
you might as well use
maybe
the serializers for that. Yeah.
Yeah, exactly, and that would be more
then
logical.
I guess if you're only running at 1 or 2.5 gigs, you don't need all
Yeah.
that much PCIe bandwidth, right? Because
Exactly.
one lane being
Also,
4 gigabits a second, 2 of them, that's
Yeah.
going to be plenty.
what I want to do is to keep 2 lanes of PCIe, so PCIe 2x, and then get two SFP with
Okay. Yeah,
with a line, and
that's a pretty nice setup.
so and that's quite easy to do, especially since it's very difficult to solder on the M2 card. But what I do is I'm using an adapter card for a regular PCI, and on this card it's much easier to solder.
Right, yeah. I mean, it seems like what might be the appropriate way to go is just to build a little adapter board that has a PCIe edge connector on one side, SFPs on the other side, and the little M.2 slot where you can put the module. So that could work pretty well.
So yeah, that's what I'm going to do, and then try to see if I can get Corundum running on this. But I have other plans for this. I have other plans for this little card. I also want to test RISC-V, stuff, synthesization, so that it's a personal project that I want to test a little bit.
Yeah.
So
well, that sounds like fun. Be interesting to know. Be interesting to know how that goes.
Yeah, that would be interesting to see.
Yeah, I guess one thing that you might need to watch out for is that if you're going to run both Ethernet and PCIe on the same group of transceivers, you might need to do some additional work in terms of handling some of the shared logic. That's possible at 1 gig. You might be able to use the CPLLs, so you won't need to worry about that. But I know I've made some. That was in one of the more recent rounds of changes that I pushed into Corundum, is some modifications to the transceiver wrapper code to support running both Ethernet and PCIe in the same bank of transceivers. So you can use 2 channels for PCIe and 2 channels for Ethernet.
Okay.
And basically the QPLL part that's shared in the common block, so that one lives in with the Ethernet transceivers, and then there's additional connections that are needed for PCIe to work properly. And you also have to poke a bunch of settings on the QPLL side in Vivado, which is the little TCL script to make it work. But yeah.
Okay.
So
well,
you probably need to make some modifications to that for Arctic 7, because I think those are very different transceivers, but that's something else you might need to deal with.
Okay, noted. Thank you.
But yeah,
I have
if
another
you run into
question.
problems with that, feel free to let me know because I figured it out, I think.
Yeah, because it would be the smallest FPGA that Corundum would run on.
Right.
And that would be interesting to know how much you can, get down also.
Yeah, definitely. Well, the other thing I will say is that I have been mulling over the idea of making kind of a Corundum light, if you will, that's really kind of strips down the data path and removes some of the fancier functionality, like either no application section or a restricted application section, simpler queue management logic and whatnot. Which something like that could be more appropriate for running on an Arctic 7 and would probably be more than capable of running 1 gigabit per second.
Sure.
So yeah, that might be something to start thinking about more seriously. Because yeah, the main Corundum design, I don't know, I'm not sure if it's going to fit on an Arctic 7 that's small, and I'm not sure if you're going to run into some major timing closure issues as well. But you'll just have to try it and be interesting to see how it works.
We have to try it anyway.
Yeah.
Another question. I have my colleague Leo that sent you a mail. Did you get it or not?
Oh, I've been having some funky email problems recently. Let me take a look and see if I can find that. Let's see. I guess you guys have been doing some work on your end as well, right?
Yeah, especially him because for me I'm not good enough for now. It will come.
Okay.
But...
Yeah, I found it.
Okay.
I'll take a look at that.
Okay, thank you. It's not very urgent, but it would be interesting to know if he's going on the right side or if it's completely wrong what he's doing. But I guess that he will have to rework a little bit the work he did because of what I heard just before. You reworked a little bit the logic, and so I think he will have to rebase in a way what he did.
Right. Yeah. Okay. Yeah. I'll take a look at what he's been working on,
Sure.
and we'll see what.
Okay.
Yeah.
Thank you.
If it lives entirely within the application section, my guess is we won't need to do much in terms of modifications to that. But it's possible if other things are also modified, then there might need to be some adjustments made.
Okay.
But
I think he's working only on the app. That's the goal.
Right.
At least it's the goal. So, okay. That's it. Thank you.
Yes, I'll take a look at that and get back to you guys with any comments. Yeah. Okay.
Okay. Thank you.
All right. Does anyone else have any questions, comments, discussion items? I guess, does anyone have any ideas about the scheduling for the meetings for 2024, right? I mean, like I mentioned at the beginning, there's two possible paths for that I've been thinking might be good options to consider. One of them is just to keep doing the same thing where we meet every other week. I guess we'll have to figure out, how the Switch meeting is going to fit into that. Well, no, I guess we already know how the Switch meeting is going to fit into that. And then the other option is to switch to doing basically one meeting per month, but then meet twice, right? So obviously you don't have to attend both, but just to provide an opportunity for people in time zones where that 9 a.m. slot ends up being at like 2 a.m. or something, that potentially could enable more people to attend that, where the 9 a.m. slot doesn't work. I don't know if people have preferences on that one way or the other.
The two meetings will have exactly the same content, right?
Well, I mean, you're never going to have exactly the same content. The idea is I would present the same slides, but beyond that, if different people attend, they're going to ask different questions. So that's why I haven't really done 2 slots until now. But I mean, the other option I was thinking of is we could alternate, right? You can keep, the one meeting every other week cadence, but then alternate. So you do 9 a.m., 9 p.m., 9 a.m., 9 p.m. So that could be another option. But yeah, anytime you have some alternating thing, then it's always like you got to get the phasing right. If you do 9 a.m. and 9 p.m., you're gonna have people showing up at the wrong time. So
yeah, I mean, maybe not try. The current rhythm fits us correctly, but
okay.
maybe
I mean,
yeah.
if people
I
like
mean,
it,
I'm
then
not
we
against the
can do
change
it.
as well.
Yeah.
I mean, oh, so
Yeah, it's like I think the 9 a.m. slot works pretty well for like people in the US and people in Europe, but I think people in like Asia and Australia or whatever, I mean, I don't know how many people we have that are interested in actually joining the meetings. You know, they kind of get the short end of the stick because that ends up being at like, I don't know, 2 a.m. or something like that, middle of the night. So that's the unfortunate thing when you have people all around the world. How do you pick a time that works for everybody? And I think the answer to that is you don't. You can't pick one time that works for everybody. Somebody has got to get the short end of the stick. So
why don't you just go with what you want to do and let's see who shows up. And if nobody shows up, then go back to what we're doing.
yeah, that's certainly an option. Yeah, I mean, the other thing too is I guess we've been doing this for a long time, so changing it up, you know, it's probably going to result in a lot of people missing the meeting. So
well, you're sending a mail each time, you know, automatic mail. So
right, yeah.
I mean,
yeah, that's definitely something I realized, that if I send out a reminder, some way, somehow, people are much more likely to show up.
absolutely. So I'm not too worried that people don't show up. I mean, with the mail.
Right. All right. Well, we can discuss.
For me, for example, I don't mind either ways, or the three things that you have commented are fine for me. So, and also, I don't know if for the Switch development meeting, it would be something similar, or what do you have in mind?
Yeah. I mean, I guess we can discuss that. I mean, probably the simplest thing to do is just to keep doing what we're doing. Just start up in January, every other week, alternating between, you know, Corundum development, Switch development. That would be the simplest thing to do, obviously. But
yeah. Okay.
Well, I'll think about it some more. We can. I just got to decide before, you know, the start of the year which path is going to make sense, and then I'll let everybody know, and we'll go from there. All right. Does anyone have any other questions or comments about anything, discussion topics?
Also, from my side, I even have time to put some HTL into this virtual FIFOs, sharing this in Brown that you have also commented during the meeting. So hopefully we have something to comment after Christmas. So yeah.
All right. All right. Well, I mean, we're pretty much at time here. So if we don't have anything else to discuss, then I guess we can go ahead and adjourn for the year. And then we'll see you guys next year. Have a nice holidays. Merry Christmas, Happy New Year, Happy Hanukkah, you know, whatever your whatever your holiday of choice is.
Feliz Año Nuevo.
Thank you.
In Spanish.
Thank you. Bye-bye.
All right.
Thank you.
Bye,
have a good time.
Thanks to everyone for tuning in today.
See you.
All right.
Bye.
See ya.
Thank you.